HBr. So we are doing a reaction with propane. So what will be the structure of propane? It's like this, right? That will be propane and reaction with the HBr. So what is the So what is the first step reaction that can explain us the Markovnikov addition? Like we know that the first is going to be H plus is going to be added to the carbon-carbon double, right? So that H plus, that's what we are going to show. So here is our 2 carbon, we can add H plus here or we can add H plus here. So let's add here. If I add H here, then I'm going to get a carbocation like this. That remaining carbon would be carbocation because both electron, 2 electrons are moving to catch that H plus. Then is going to be the Br minus, the other part. But we can add the another way, we can do whatever if I add hydrogen in this carbon, then my carbocation is going to be on the other side because the one of the bond is going to take that H plus, right? So either we can add H plus, this carbon can take or that carbon can take, depending on what. If the whoever is gaining the H plus, the other carbon would have one less electron. So it should have the carbocation. Now, based on that, what is the question? What is the intermediate form in the reaction of propane with HBr? Now we need to, these are the possibility. Now, which carbocation is more stable? Is the primary carbocation more stable or secondary carbocation more stable? This is primary carbocation, right? Because this carbon is the carbocation and it is attached to only 1 carbon. Whereas this is the carbocation, it is attached to 2 other carbons. So this is 2 degree, this is 1 degree. And we know that 2 degree carbocation is more stable than the 1 degree carbocation. So that is tell us that this would form, that is not going to form because the stable carbocation always forms. So that is telling us then the 4 is the answer, right? Make sense? Any question there? What is the IUPAC name of the organic compound shown below? So the structure is given now. What is our target? To have the IUPAC name. Find out the longest chain, right? So which one is going to be the longest chain? Right? That is going to be the longest chain. So then which way we should start numbering? From this side or that side? OH has the higher priority over the substituent methyl, right? So this is methyl and this is OH. So that will take the higher priority and OH is a functional group, so it is the parent name. So 1, 2, 3, 4, 5, 6. So our carbon chain is becoming 6 carbon chain. So we have hexa, and then because it is all, so hexanol, we can tell, right? And where is the all located? So 2 hexanol, and where is our? Oh, it is not hexanol actually because we have a double bond also, right? So it should be hexene, not all. We have multiple functional groups, so we should have hex. And then where is the in located? This is in, part of the in. So in is at the 4th position. So 4 in, and all is located at carbon number 2. So 2 all. That is making more sense, right? In is located at carbon number 4 and all is located at carbon number 2. Now, methyl is located at carbon number 5. So that is 5 methyl. 5-methyl-hexene 4 into all. So where is that one? B. So I know probably some of you start counting from here. This is you thought that this is the carbon number 1. But remember, you need to count your carbon chain when you can go only one direction. Do not stop at a carbon where you can just go in any direction. Like here, you can go this direction, you can go that direction. That is not the right carbon. Yes?
If that double bond was a triple bond, would you start numbering from the other side?
No, double bond and triple bond has the same value. Double bond and triple bond is the lower level in the naming the organic compounds. Alcohol has in the middle range. So alcohol has the higher parity over alkene or alkyne. So then number 2, which of the following is not able to exist as cis-trans isomers? So we need to know the structure of that one. 1 dichloro 1 butene. So 1 butene, 1, 2, 3, 4, that is butane. Now 1 butene, that means we should have a double bond here. And we have 2 chloro at 1 position. So this is 1, 2, 3, 4. That is 1, 1 dichloro 1 butene. Now, will it exist or will it show cis-trans isomers? What was our requirement? Here is the hydrogen, right? We can show like that, sending hydrogen. Now, if I close it here, both groups are identical. So if they are identical, cis-trans isomers are not possible. Although this side is different, but we need to have both sides different. So that is telling that cis-trans isomers are not possible. What is our question? Is not able to exist as we are actually looking for the answer, not 1, right? So that means this is our answer is going to be. Because we are looking for the negative answer. So that is going to be one of our answers. It will not show cis-trans isomers. 1 dichloro 1 butene. So again butene, 1 butene, and this time 1 and 2. 1 and 2 dichloro. So now here is the hydrogen. Now again, if I stop this carbon, now these two are different. So cis-trans isomers possible for this side. Now I should look for the other side. One is the chlorine and another is the ethyl. So again they are different. So cis-trans isomers possible. So this is no, this is yes. So that is not our answer because our answer is negative answer. 2 butene. So 1, 2, 3, 4. So 2 butene. Here is the double bond. Now will it show cis-trans isomers? Yes or no? Here is the hydrogen. I can extend. Here is the hydrogen. So now stop it. Hydrogen and methyl, 2 different things. Stop it. Hydrogen and methyl, 2 different things. So again it is yes. So that means it is not our answer. 2 chloro, 2 butene. So 2 chloro, 2 butene. So again, if I stop this side, they are different, right? Chlorine and methyl. So cis-trans isomers possible for this side, whatever the other side. Other side we have a hydrogen here. So hydrogen and methyl. So again it is possible. So this is again yes and negative answer. Make sense? Now let's see which one is the next. Do you have anyone? Okay. Which is the major final product of the following two-step reaction? And the hint is given. Hint which product you get after the first reaction, that means after the first arrow, the first product is going to be your reactant for the second reaction, second arrow. So what is going to be the product here? This is equivalent to H2SO4. So that means the acid, phosphoric acid and any other acid, if we heat alcohol in presence of acid, we are going to have dehydration reaction. That means the alcohol is going to lose a molecule of water. So dehydration reaction, this is our alpha carbon, this is our beta carbon, so we have only one beta carbon. So take away that OH out and this hydrogen out, so that means we are going to get, and that would be our skeleton, and so now we are going to have a double bond CH2. Because OH and H will leave the molecule as the water. Dehydration product, so this is the alkene we are going to have. Now after having the alkene, now if we add hydrogen in presence of a catalyst like platinum, palladium or nickel, we can do hydrogenation reaction, that is addition of hydrogen to the carbon-carbon double bond. So that means this bond is going to be broken. One hydrogen atom would be added here, another hydrogen atom would be here. So that means we are going to get that is going to be the product. So we say C. We have even discussed this type of problem on Friday, right? Similar problem we have discussed on Friday. So any other problem you want me to discuss? You can also come to my office if you have questions.